Students, this is Unit 6, Polygons, Lesson 6.3, Rectangles, Rhombis, and Squares. Please take a moment and get the date, time, location, as well as a parent or guardian sign-off. Quick recap. This is a parallelogram. Your job is to find the variables x and y. Number 2, if a regular polygon has a single exterior angle that is 36 degrees, what is this polygon called? Do this work on your own, then restart the video. Pause. Welcome back. So right here, first thing you want to do is, we know that opposite angles are congruent. The problem is we cannot make these equal because they're two different variables. So we have to use another property. Hopefully you remembered that these guys add up to 180. So right here we have 115 degrees, which is going to make right here 65. So I have 5y equals 65. Y equals 13. And then opposite angles are equal, so that this is 7x minus 5 equals 65. X equals 10. This is a regular exterior, so we have one exterior angle equals sum over sides. And in this case, we're going to replace one exterior angle with 36. Cross multiply. And of course, n is 10, but I don't ask you just for the number of sides. It is going to be called, of course, a decagon. So last class, we focused on the singular shape of a parallelogram. Today we're going to talk about the family of parallelograms, which includes a rectangle, a rhombus, a square. The word perpendicular is going to come in several times, and quadrilateral. First, let's recap what OCD stands for. Oh, excuse me, that first one is not congruent, it's parallel. Definition of a parallelogram. Opposite sides are parallel. You should be marking these on the diagram as a recap. Congruent. Opposite angles are congruent. The consecutive angles, of course, those are the angles next to each other, are supplementary. And last, these diagonals cut each other in half. That is the essential definition. In other words, it's a midpoint going both ways. So the diagonals bisect each other. Okay, these are the OCD qualities of a parallelogram. It's very important you have these memorized because the family of parallelograms, which includes rectangles, rhombis, and squares, kind of like tigers, lions, and bears from The Wizard of Oz, all have the OCD qualities. So let's focus first on a rectangle. So a rectangle, if I take a parallelogram, so I start with a parallelogram and I make 4 congruent right angles, then we get a rectangle. So the essential definition of a rectangle is a parallelogram with 4 congruent corners, which of course by implication implies 90 degrees. Therefore, a rectangle is a parallelogram with 4 right angles. A rhombus, if I were to take a rhombus, a parallelogram, and make, instead of 4 equal corners, if I had 4 equal sides, then I get a rhombus. So a rhombus is a parallelogram with 4 equal sides. Now, there are additional qualities besides those simple definitions. So if I have a parallelogram, it's really important you understand that both a rectangle and a rhombus have all the OCD qualities because both shapes qualify as a parallelogram. But they have a couple unique qualities. Okay, for the rectangle, the first unique quality is, of course, 4 right angle corners. The second unique quality is that the length of one diagonal, draw that in, compared to the length of the other diagonal is exactly the same. So you have congruent length diagonals. Congruent length diagonals. And since we know that this is a midpoint goes both ways, we automatically have now 4 congruent pieces, which by implication, watch out for this, this is going to come into play quite a lot, which means I have 4 isosceles triangles. Now for a rhombus, what makes a rhombus a rhombus? We have 3 unique qualities, actually. One, we have 4 congruent sides. That's what makes a rhombus a rhombus. There's also 2 things special about these diagonals. Go ahead and draw them in. The first and most important is the fact that these diagonals are perpendicular, which means we have right triangles all the way around. So the first thing here is the fact that the diagonals are perpendicular. And the second thing is that the diagonals bisect the corners. They cut the corners in half. It's an important quality. The diagonals bisect the corners. Okay, so these are the unique qualities of a rhombus, and these are the unique qualities of a rectangle. This is the quad family tree. I just listed these qualities. Remember, both of them have OCD qualities. You're going to need to memorize this part of the quad family tree. Then, finally, you take a rectangle with 4 right angles. You take a rhombus with 4 congruent sides. They get married, they have a kid, and the kid is called the square. So a square has all the qualities of both a rectangle and a rhombus combined. We're going to solve 3 simple problems here, keeping in mind the qualities of each of these shapes. It says, in the rectangle below, trace and mark the given information on the diagram, then find all possible angles and sides. Notice it says all possible. So step number 1, we are given that e to I, I'm going to color code this in red, is going to be, make this a little bit smaller, 2x plus 1. And then I have f to h, which is this whole thing, is 3x plus 10. And then this angle IFG, FG right there is 51. Okay, I'm going to work with the segments first. Things before algebra. That's super important. Things before algebra. So I'm going to talk about this segment EI, the red segment. And I'm going to compare it to FH, the blue segment. It's very important you just don't automatically stick an equal sign because those are not equal. What you do know, however, is that 2 of the reds equals 1 of the blue. 2 EIs equal 1 FH. So let's work that algebra out. So I have 2x plus 1 equals 3x plus 10. I think about things before I think about algebra. Now the algebra is relatively easy. Follow along. X equals 8. Let's make sure this works here. So that means e to I is 2 times 8 plus 1. Of course, that's 9. And then f to h is 3 times, e to I. Let's go ahead and double check our math there. E to I is 2 times 8, which is 16 plus 1 equals 17, of course. And then we have f to h equals 3 times 8 plus 10, that's 34. And then you just double check. 17 is half of 34, and we've got that correct. Now let's focus in on this angle, find all things possible. Remember, we have isosceles triangles all the way around here. And our right angles are in the corner. So that 51, if we have 2 equal sides, we have 2 equal angles. So we have a 51 here. Because 2 equal sides, 2 equal angles. Keep that in mind. 2 equal sides, 2 equal angles. And then we can take the 51 away from 90. It's going to give us 39. Because it's isosceles, we can walk it over to the other side. Take away from 90, and of course you get 51. Now we can get those angles in the middle, because remember, right here, that triangles add up to 180. So 51 plus 51 is 102. Take away from 180, and we got ourselves in the middle here, 78. 78. 102, because it adds up to 180, 102. Okay, looks like you found everything. Looks amazing, so much work, but wait, there's more. Looky here, folks, watch very carefully. We don't ignore these right angles. Remember my warning about the last unit and right triangles? Looky there, friends. We got ourselves a right triangle. let's pull this triangle out and let's see what else we can find with it. Okay, so this triangle, we're going to go ahead and pull it out. EHG. We already have ourselves some angles. We've got 39 degrees there, 51. This entire length, of course, is 34. Now we can solve for the outer edges. Right here, E to H and H to G. Doesn't matter which angle we're going to work with. I'm going to go ahead and work with the angle 39. Follow along, folks. This should start ringing a bell, kind of giving you a creepy feeling. Remember, I warned you. SOHCAHTOA, all that right triangle stuff's going to come back. So from the 39, this is opposite, adjacent, hypo. I'm going to go for EH first. So I've got an OH combo. So that's sine of theta over 1 equals O over H. You're going to follow along, folks. Our opposite is EH. Our hypo is 34. We cross multiply. So I have sine 39 times 34 equals what we want, which is E to H. Unknown is by itself, so now it's calculator time. 39 sine. You should be following on your calculator. Make sure you're getting the same thing. Times 34. I'm going to take this to the first decimal place because that's going to round up there. So 21.4. Let's put that up there. Whatever you get on one side, you can get on the other. Now I'm going to go for this one, which is an AH combo. Cosine cosine theta over 1 equals our adjacent, which is HG, over our hypo, which is, excuse me, we're supposed to put the variables in there first. No shortcut, students. Equals adjacent over hypo. Cosine 39 degrees, put parentheses around that. Equals our adjacent, which is HG, over our hypo, 34. So cosine 39 times 34 equals what we want, which is our HG side. Back to your calculators. 39 cosine times 34. Take that to the first decimal place, 26.4. It makes sense for that to be a little bit longer because it's the longer side of the same rectangle. All righty, be careful, guys. When I say find all things, make sure you actually find all things. I'd like you to pause the video and do as much of this one as you can on your own. All right, take a look. Let's see how much far you got here. We are told that P to R is 10. So I'm going to automatically break that down to 5 and 5 because I know that's bisected. And QR is 13. And you were told the measure of TQR, that's this angle right there, is 23. It says find everything you can. Most important thing you need to remember about a rhombus is there are right angles right in the middle here. So step one, we're going to find the other sides. We have a right triangle here. I'm going to pull that out. I'm going to call this segment X. X, 5, 13. Have two sides, need third side, Pythag. So we're going to go leg squared plus leg squared equals hypo squared. Circle, plug, chug. Follow with me, guys. Okay, so we just found that this segment length here is 12, which means this is also 12. What else can we find? If one side's 13, all of them are 13 because all sides are equal. Angles are easy. Ready? In a rhombus, they're bisected. So if that's 23, this is 23. That means this whole thing, of course, is 46, which means this is 46 because opposite angles are equal. You can walk that 23 over. And then because we have a right triangle here again, and take that 23 and subtract it from 90. And of course, we get 67. That's 67. This is also 67, which means over here is 67. This is 67. And of course, that means this entire angle is 134, 134. Rhombi, the plural of rhombus, is so easy. So much fun because it's so consistent with right triangles. Here we have a square, friends. You're only given one piece of information. See what you can do with this on your own. Pause the video, restart when you're done. All right, let's see what you got here. You were only given one piece of information here. In fact, that was AC is 12. What can we do with that? Well, step one, you should have immediately split it up, which you can do. The whole thing is 12, whatever you choose. I go like this. And because I have right angles, because it's a rectangle, and these angles are bisected because it's a rhombus, which means I have a bunch of 45, 45, 90 triangles here. So right here, this entire side is 12. So you're asking yourself 45, 45, 90, what times root 2 is 12? Wow, you thought you got away from that. Well, guess what, friends? You didn't. Something times root 2 is 12. And then you backtrack. All four sides are equal. So much information. Squares are so easy. Just keep in mind that you're always going to have 45, 45, 90 triangles if it's a square. Students, take 2 minutes, recap what you have learned on each of these pages verbally. That'll help reinforce the material for the long term.